Hello everyone, my name is Pranali Kedari and I have done online embedded system internship at Emertex Information Technologies. I'm going to talk about the project called Washing Machine Simulation using PIC16F877A microcontroller. So let's start. Here I shows the content which I'm going to talk about, starting from introduction about embedded C and embedded system, about microcontroller, PIC microcontroller, software use, peripheral use, and I will show the demonstration about washing machine project and at the end I will conclude the project. So let's start. Introduction. Washing machine is a common household appliance that simplifies daily chores. Today, everything around us is becoming automated, whether it's self-driving cars, smart home systems, or industrial robots. Automation helps in making tasks more efficient, fast, and reduce human effort and errors. One simple and relatable example is the washing machine, which we don't think about, but it washes, rinses, dries your clothes automatically once you press a button. So, in this project, we are simulating how a washing machine works at a basic level. We are using PIC16F877A microcontroller to control the system. The controller takes inputs from buttons like start or mode, and based on the input, it runs a specific washing sequence, showing the stages on LCD and controlling a motor. The simulator replicates the basic functionalities of washing machine through embedded programming. Now embedded C. Embedded C is an extension of C programming language used in embedded system. It supports fixed point arithmetic, name address space and direct hardware access. In order to make the microcontroller do something, we need to program it. And the best language for that is embedded C. Why embedded C? Because it gives you direct access to hardware. It gives less memory and runs faster than higher level language. It's portable, meaning you can use the same logic on other controllers with little change. Here, let's see how we use C in our project. Variables and data types let us store data in memory efficiently, like the current stage or button state. Pointers allow us to access specific memory location such as hardware register for input-output pins. Controller structures helps in reacting to inputs like button presses. We split our logic into functions so the code is clearer and reusable. We use macros and hash define to write flexible and hardware specific code. Without embedded C, we would not be able to tell our microcontroller what to do in different situations. Next, embedded system. Embedded system is a system that performs a dedicated task and it combines both hardware and software. Unlike general purpose computers, which do everything from browsing the web to playing games, embedded systems are meant for a single or limited function. For examples, microwave oven, it controls time and heat based on input like fitness band, measures steps, heart rate, etc. Smart TV, it handles display, sound, network and remote inputs. Medical devices like monitor vital give alerts. Industrial robots, which perform repetitive tasks with high precision. In our case, the embedded system is a washing machine controller and its job is to follow a washing cycle based on input and give output accordingly. Next, microcontroller. Microcontroller is a compact integrated circuit containing processor, memory, input-output peripherals. It is programmed to perform specific control tasks within embedded system. We can also say it as a microcontroller is a brain of embedded system. It's a tiny computer on a single chip which includes processor, memory, input-output ports to connect sensor, displays and buttons. It doesn't run without Windows or Android, but it runs on program at a time, fast and efficiently. In our project, the microcontroller takes input like start button press, presses them using the program logic and then give output like turning on a fan or displaying a message. We are using PIC16F877A, which is very popular for learning and hobby projects. Next, PIC microcontroller. PIC microcontrollers are made by microchip technology and they are widely used in industry for low cost and medium complexity embedded applications. Our chosen controller PIC16F877A has 8-bit microcontroller processor, 40 pins with lots of input output, built-in analog and digital converter, timer and interrupts, support for USR, SPI and I2C. But I have chosen this only because it's easy to program. It has enough input output port for LCD, motors and buttons. It can handle real-time control. It's perfect choice for simulating a washing machine. Next, the software we have used in washing machine project. To build and test the project, we use a few software tools. First one is MPLAB XIDE. This is where we write and compile the embedded C code for a PIC microcontroller. Next, PICSimLab. This is virtual simulator environment where we can test our code with virtual hardware without needing any physical component. And X8 compiler for compiling code for PIC16 series. Peripherals used. We use the following components in our project circuit. PIC16F877A, the main controller chip, 16 cross 2 LCD to display washing stages like washing, rinsing and done. Push button for user input, start stop and mode selection. Fan act as a motor simulation. When washing alerts, the fan turns on. Crystal oscillator provides a stable clock signal to the microcontroller. Resistor capacitor used for signal conditioning and stabilization. Next, we will show the project demonstration. Here we have written code for our project in MPLAB XID. Here I have shown header files which include CLC, CD, digital, keypad, main program, timer, and washing machine header. And here source files CLC, digital pad, ISR, main, timer, washing machine functions. This is the project code I have written here. Main project. So after writing this, we have to build it. Build main project. Here it shows build successful. Later we have to go to Pixim lab. Pixim lab contains LCD. There are two types 16 cross 4 and 16 cross 2. We are using 16 cross 4 LCD. It contains matrix keyboard, LCDs. Here it is buzzer, fan, and showing microcontroller we are using PIC16F877E. So here we need to select the board. Here it is, PIC Genius. Later we have to select the microcontroller, PIC16F877E. Later we have to load the hex file. It's here. Once it's done, it's showing the LCD showing press key 5 to power on washing machine. Key 5 means RB4. You have to press this. It's showing powering on washing machine. Now it's showing different programs. There are many programs. For that, for scrolling down, we need to press RB3. Daily heavy dedicates. Next. It's adding heavy dedicated whites. Next add stain wash. You have to press RB3 again. Scroll down. Eco cottons. White stain wash eco cottons. It's showing eco cottons, woolens, bed sheets. It's added a rinse plus dry. Dry only. Wash only. Aqua store. Wash. Again it's come to start daily. So I'll select heavy. And for select after selecting heavy, we have to for selecting heavy, I need to long press this RB3. It will show water level which contain auto, low, medium and different parts. For scrolling down, I need to again press RB3, low, medium, high and showing max. So I will choose water level as medium and I will again long press this RB3 for choosing medium. So it will show press switch SW5 for start and SW6 for stop. Means I have to press RB4 for start and RB5 for stop, RB4 for start, RB5 for stop. So I'll press RB4 so it will start. And here fan is running and here timing also showing. The function is washing. If I want to pause, I need to press RB6. SW6 means RB5. If I press, it paused. Again, if I want to start, I need to press RB4. Again, it starts. After washing, it's showing the function rinse. It has completed the spin function also, and it is the buzzer is beeping and fan has stopped, and it is showing buzzer has buzzed and fan has also stopped, and it shows program completed. We can take clothes out. This is the project, and again it is showing the programs from initial. So we have done project demonstration, project demonstration. Next, the conclusion part. This project is not just about a washing machine, it's about understanding how embedded systems work in real life. For coding in embedded C to interfacing hardware to simulating and testing, we covered a full embedded system development cycle. We learned how microcontroller can control real world devices using logic and timing, and this Same concept can be extended for other applications for home automation, smart agriculture. It's a great foundation for anyone looking to build a career in embedded C, and it integrates peripherals and embedded C programming for functional prototype. So this is all about my project of washing machine simulation. Thank you everyone.